All right, here's the problem. This is just a density problem. So just as a reminder, density gets the symbol rho. The actual value of it is the mass of something divided by the volume. The mass, the usual units that we use are the mass is in grams and the volume is in cubic centimeters or centimeters to the third power. All right, so and that's what this means right here. Mercury is, calculate the density of mercury in grams per centimeter cubed. And then the radius of Mercury is given right here, 2,440 kilometers, and the mass is 3.3, and that E23 means times 10 to the 23rd kilograms. All right, and we have some conversions right here that we're going to use. All right, so let's get started. So the first one is to let's get the mass. All right, so the mass. Remember, it says that the mass has to be in grams, and of course we are in kilograms. So let's write that out. So it's 3.3 times 10 to the 23rd, and of course it's kilograms. All right, and so what you do is you say, all right, well that's fine. I'm going to use this conversion right here. I know that 1 kilogram. And I'm canceling the kilograms, so the kilograms go in the denominator, is 1,000 grams. All right, so the kilograms cancel, and that gives me the number of grams. Now, 1,000 is also 10 to the third, so this becomes really, really trivial. It's you just add the 10 to the 23rd plus 10 to the third. You just add the exponents. And so this becomes 3.3, right? That doesn't change. But now it's times 10 to the 26th, right? 10 to the 26th grams. All right, very nice. So now we have the mass. All right, now the volume is a little bit more complicated. First of all, let me write the volume of anything that is spherical, and if anything is large enough to self-gravitate, it self-gravitates into a sphere. Things that don't do that, for example, that are too small would be like many of the asteroids. They're potato-shaped looking things. But things that are larger than asteroids, minor planets and so forth, and certainly Mercury is a full-fledged planet. They have they are spherical, and so the volume of any sphere is equal to 4 times pi divided by 3. This is just from geometry, times the radius to the third power. All right, so that's just a basic thing from geometry. Now, the radius, we need to convert this 2,440 kilometers, right? We have to convert that into centimeters, all right? So we have two conversions that we're going to use, all right? So here we go. So I'm going to put this straight down here. So we're going to start out with what it gives us in the problem is 2,400. That's a 4. Shoot, that's a 4. There we go. 440, of course, kilometers. I don't know why I'm writing uphill here. All right, and so I'm going to use my first conversion. 1 kilometer is I'm going to write it like 10 to the third. That's a 3. 10 to the third meters, 1,000, right? 1,000 meters is also 10 to the third. And then I'm going to, so notice the kilometers cancel. And so, 2,400, maybe that's a 4 right there. 2,440 times 10 to the third is now in meters. But let's go even further, and we'll do another conversion. And we know that in 1 meter, there are 100 centimeters, which can also be written as 10 to the second. I mean, you can write 100 as well. That's perfectly fine. Centimeters. And so the meters cancel. And so 10 to the third times 10 to the second, you just simply add the exponents. We did that with the mass, right? Similarly with the mass. All right, so this becomes 2,440 times 10 to the fifth centimeters. All right. All right, so that's still the radius. That's just simply the radius. Now we have to plug that radius in, so that has to go into this formula right here. So we have to cube that, all right, and then multiply it by 4 pi and divide by 3. And keep in mind, we know what the mass is, right? So the mass is 3.3 times 10 to the 26 grams. I'm going to pause and rewrite this. So that it looks nice, and then we're going to do the calculation for the volume. Okay, so that's this calculation right here. All right, so we're going to calculate the volume with this radius, which is now in centimeters. All right, so I've rewritten this just to get a nice clean screen here. So the mass, as you recall, is 3.3 times 10 to the 26 grams. We did a conversion for that. And then we converted our radius into centimeters, so it's 2,440 times 10 to the fifth centimeters, but we have to cube that. So when we cube it, let's make sure that looks nice. That's supposed to be a 5. So it should be, it'll be, you still have to multiply by 4 times pi divided by 3, and cubing this number here gives you 1.4527. I mean, it keeps going after that, but times 10 to the 25th. And notice you cubed the centimeters, so it will now be centimeters to the third power. All right, so now we're going to multiply that number. Now I didn't round it in my calculator, and you shouldn't until the end, right? So until the very end. So you're just going to multiply this number that's in your calculator. Mine is 1.452678 times 10 to the 25th. All right, so I'm multiplying that times 4 pi divided by 3. All right, so times 4 pi divided by 3. All right, so this is what I get for the volume. And I'm gonna actually complete the problem here. So I'll have to write the volume anyway. So the density, remember that we get the symbol rho. That's what that P-looking thing is. That's rho, also known as density in the sciences. Anyhow, it's going to be the mass divided by the volume. So the mass is 3.3 times 10 to the 26th grams divided by. So now this is the answer that I have in my calculator. Again, don't round it until you've completed the calculation for density. All right, but anyhow, this is I'm not going to write all these digits out. So this is going to be 0.84965 blah blah blah. I mean, it keeps going. Anyhow, I'll just put a few of these digits. 0.84965, and then of course it's time. And there's more digits after that, but times 10 to the 25th, and that's of course in centimeters cubed. All right, and just as a reminder, the reason that we do this is because the density of liquid water, fresh water, this is H2O, right? Fresh H2O is 1 gram per centimeter cubed. All right, so the Earth, for example, has an average density of 5.5. So now we're about to figure out what it is for Mercury. All right, so for the planet Mercury. So I'm going to take the number I have in the numerator, 3.3 times 10 to the 26th, and divide it by, well, it's already in my, the 6.0 blah, 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 times 10 to the 25th is already in my calculator. So I'm just going to use the unrounded number in my calculator. All right. So 3.3 times 10 to the 26th divided by answer. All right. So now we're going to round it. Let's see. I can't remember. Did they say to round? Let me look at the problem real quick again. I got to look back. Anyhow, let me just write out the answer. So it becomes, as a reminder, Earth is 5.5. So this becomes, this is, the density of Mercury is 5. I'm going to round it to 2 places past the decimal, 5.42. All right, 5.42. It's 5.4232, blah, blah, blah. But 2 places past the decimal, or even 1 place past the decimal, I imagine that's probably what I asked for in the problem. I haven't looked at it, at the actual problem. Remember, you always have to read the problem. Anyhow, it's in grams per centimeter cubed. All right, so this is rounding it to 2 places past the decimal. Rounding it to 1 place past the decimal, it would be, of course, be 5.4 grams per centimeter cubed. All right, so that's probably that's probably what we want, is rounded to 1 place past the decimal. All right, so there's the completed problem. This is something that we'll do in lab, or you've already done it in lab, depending on when you're watching this video. All right, very nice.